In this video, I'm going to talk to you about up and running with Java Microservices. So microservices is an adoption that as software engineer have shifted in recent years, and it's one that you should be aware of and how to basically get up and running with it. My name is Nelson and I'm the founder of Amigoscode, and you can reach me at Amigoscode on all social media platforms. So welcome to DockerCon 2022. So let's start this talk by understanding what a monolithic is. So in a monolithic architecture is when all the processes are tightly coupled and they run as a single service, right? So you can imagine where you have a bunch of different applications or services, right? So if you run the application, all these different services, they actually are segregated usually by their own API endpoints. Now, the microservices, the software is composed of small independent services that communicate over well-known defined APIs. Now, the key in there is small independent services. Independent. Now, both monolithic and microservices, they are architectural design, meaning that you can choose to go with a monolithic when it makes sense, or if things are becoming a little bit more difficult to handle deployments and whatnot, then you can choose microservices. So what microservices really gives us, right? So this is the key question here. Well, one, the services are loosely coupled. They are independent deployable, meaning that if I've got my team that is working on a customer application, for example, and you've got your own team which is working on the fraud application, then you can deploy those independent. You can reuse code, right? So you can have one microservice that has a well-known defined API, and then a bunch of other microservices can actually consume the functionality from that microservice. It's organized around business capabilities. So you might have users, fraud, notification, payment, and a bunch of other different capabilities. It's also owned by small teams, highly maintainable. And the last point is polyglot. This means that there is no restriction on the technology stack that you can choose for each of the microservices. So you might have one microservice which makes complete sense to build in Java. Then you might have another microservice which makes complete sense to build in Node, for example, right? So you don't necessarily have to stick with one tech stack for the entire set of services. Now, to help you visualize microservices and monolithic, basically just take a look at this example, which is basically what I've just discussed. Monolithic, basically the application as a whole. So you can see that we have different business units, so customers, fraud, notification, and the list could go on and on and on. But on a monolithic application, everything is encapsulated and they work together, right? Whereas in a microservices architecture, things are independent. So customer is its own application, fraud, it's its own application, notification is its own application. Instead of having one application, you go from 1 to 3 separate applications, and then you have full control of how you build, you deploy, you maintain, so on and so forth. Now, obviously, there's a question where, okay, shall I use microservices or monolithic, for example? Well, it depends, because having one unit to deploy, maintain, and test, it's much easier than having a bunch of different moving parts and then making sure that those parts indeed work. So if we take a look at this diagram, which is from microservices.io, so here this is a basically a bunch of questions from the microservice architecture, right? So do you have one single service per host, multiple services per host? Maybe if you're adopting Kubernetes, then that would make more sense. But again, it involves more effort in terms of putting all of these things together. Then communication between these microservices, right? So if microservice A is talking to microservice B, and the network call fails, how do you handle that, right? So maybe you want messaging. Then you have things such as API gateway, you've got externalized configuration, testing, so service integration contract testing, distributed tracing. So you want to make sure that, if the service goes from A to Z, then you want to trace all the network calls and whatnot. So you can see that it's actually more involved for you to get microservices up and running. But once you do, and depending on your use case, if it makes sense for you to go microservices, before I show you microservices in action, let me show you the Spring Boot official page. All right, if you want to follow along, navigate to spring.io. And in this page, you can see that they basically have what Spring can do for you. So basically, you are interested in microservices, reactive, cloud, web apps, serverless, event-driven, batch, and whatnot. You can see that they also have a small example of how to get up and running with Spring Boot, which is really, really easy, to be honest. Now, in here, you can see that they have projects, and in here they have projects, and the project that allows you to build microservices is Spring Boot, and also in combination of, for example, Spring Cloud, Spring Data for databases, security, and others. So let me navigate to Spring Boot. And here you can see the documentation. So you can learn about Spring Data, Spring Cloud, Session, Kafka, Vault for secrets management. So they have integration for everything. And also, if you want to learn, you can basically just click on Learn, and they have the reference documentation, which is really, really extensive. So if I click on it, you can see that I can click on this button, for example, and it takes me straight into the documentation. You can see that is very well put together. Now, this is basically documentation, but how do you get up and running with Spring Boot? Well, if I open up a new tab in here and search for Spring Initializer and go to this link, start.spring.io, and in here we can actually configure our application. So if you want to configure an application using Spring Boot, you can choose the project, Maven, Gradle, even the language. You can use Kotlin if you want, or Groovy, and then you have different versions in here, and depending on the build tool that you choose, either Maven or Gradle, then you have to specify the project metadata, and also you can choose the packaging, whether it's jar or war, and the Java version in here. So 17 is what I recommend most people these days, because it's the latest one and the one that has the long-term support, I think since 11, if I'm not mistaken. So then you see dependencies, and basically here you can actually pick a bunch of dependencies. So if you want to build RESTful applications, Spring Web, this is the one that you should use. It uses Apache Tomcat as default embedded container. If you want to, for example, let's have a look, secure your microservices, Spring Security. If you want to use SQL, you've got JDBC API, you've got Spring Data JPA, which uses Spring Data, database migrations in here, Flyway, Liquibase, NoSQL, you've got Spring Data Mongo, Apache Kafka, RabbitMQ integrations, if you want to send them emails, Spring Boot actuators for metrics, Prometheus, and you can see the list is on and on. Service discovery, Open Feign, and whatnot. You can see that there's a lot to it. But the good thing is that you just pick one project and then you learn that. And if you need to integrate another project, for example, let's say Vault, then there's a specific project for it with its own documentation, which is really nice. So what I'm going to do now is I already have a project which I've already set up, and I want to walk you through how everything is put together and then run the microservices, and then you see everything in action. And I also have a really nice diagram. So if I open up IntelliJ, and in this simple project, I have a README in here, and I just want to walk you through the architecture in here when you want to build something which involves microservices. So usually you have your public network. So this is where the users basically interact with your application. And the first thing that they do is they basically hit a load balancer in here. Now, it turns out that we can actually use a load balancer, which is provided by Spring, or you can choose one which is provided by the cloud provider, i.e. a managed load balancer. So depending on which option you want to go for, you can decide which one is best for you. But as you start, it's best for you to learn how to put things together and understand how to configure and whatnot. For example, path-based routing right here. So the client sends a request. This, for example, wants to talk to this customer microservice. Then / customer, it goes to this service in here. And one thing to stress out is as you build microservices, each microservice should have its own database. So again, we are moving from monolithic. So with monolithic, you have one service which has a bunch of services together, and they are deployed as a single unit, sharing the exact same database. With microservices, that changes, and each service or each microservice has its own database. And the cool thing is, so the microservice itself, if for example wants to use anything other than a relational database, for example MongoDB, then it can absolutely do it. Also, if you want to, for example, introduce a message queue in here, because you can imagine if we have this microservice talking to this microservice right here called notification, if this one fails, then that's it, the whole request fails. But what you want to do is you want to basically store that into a message queue, and it doesn't matter if this microservice is down, but eventually the message will be delivered. And this is why you need a message queue in here. So, you know, usually Kafka is quite popular, SQS from Amazon, RabbitMQ. So depending again on your use case and why you need to choose one over the other, then that is a decision that you have to make as a team. So basically you can see that these microservices, they communicate to each other. So the blue arrow is the internal communication from within the private network in here, and this is actually the public network. Also in here, so for these microservices, you know, these days the way that we package these microservices or services is by using containers, right? So you want to have maybe a private registry that only you can actually pull images from. You don't want your images to be public, because you will basically containerize or build an image for each of the microservices and then run containers from it. So you need somewhere to pull images. Also, you might want service discovery, right? So this is Eureka Server. So this is actually when you are using things not the right way. So maybe if you're not using Kubernetes, then you might need to use Eureka Server. Otherwise, you know, if you're deploying to Kubernetes, Kubernetes gives you service discovery for free. Also, configuration management. So how do you centralize configuration? And then you have Sleuth, and more specific with Zipkin. And here, basically, this allows you to see all the traces that flow through your system. So if a request comes from the public network, reaches the load balancer, goes to customer, then fraud, then from fraud goes to notification, then you can see exactly the entire flow of the application. So this is what this gives you. Now, this is basically an overview, and obviously we can't really cover everything. So let me just show you customer microservice and fraud microservice and how they talk to each other. So in here, I'm going to open up the project tab, and I already have a Docker Compose file in here, and this defines a set of services that we need. So I said that each microservice needs its own database. So within this Docker Compose, I have services, I have Postgres, so I'm using a relational database. For the container name, I've just named it Postgres, the image is Postgres, 3 environment variables, so the user, the password, and then PG data. So this is me changing where the data is stored within this container. Then we have volumes. So in here, so we have Postgres. So this Postgres maps to data / Postgres, which is this guy right here. And this Postgres volume is the one that I define in here. So this Postgres. Then we have ports. So we are exposing 5432. So this is from the host mapping to the container. The same for networks. So we have one network called Postgres. And this network in here is so that we have another service called PGAdmin in here. So this allows us to basically interact with our database using a GUI client. And I've got the password, so how we connect to it. And we mount the volumes, so PGAdmin to var lib PGAdmin, some ports 550 mapping to 80. So this is what the container is running on. And then the network, so that these two, so PGAdmin, so this container can talk to this container via the network. Now, let me actually just basically run this from here, and you can use Docker Compose up if you want, but within IntelliJ, I've got the Ultimate Edition, and the integration is quite nice, to be honest. So now it's up and running, and let's basically open up Docker Desktop. And in here, have a look. We have microservices. So this is the name of my project. And within it, I've got PGAdmin, which is running in here. And also have a look, Postgres and the ports as well. Now here, obviously, you can basically open in browser. You can bash into it, execute a shell command inside of this container. You can restart, and you can also delete. So let me just click on open in browser. And you can see that this window opens. So let me just add a password in here. So I'm just going to say password. And now I need to never save this. I need to basically create a new server. And here I'm going to say Docker and then con and the connection. So this will be Postgres. And the reason why this is not localhost in here is because I've named my container Postgres. So now in here, the PGAdmin container is talking to the Postgres container via the Docker network. Then the username here, I think I said Amigoscode, and the password was password. So if I save this, hopefully I should connect. There we go. And now I'm inside of this server right here. And currently I have two databases, Amigoscode and Postgres. So let me create two databases. So here I'm going to create one database for customer. So we need a customer database for our customer microservice, but also let's create one for fraud. So fraud. So save, and nice and easy. So now we have 4 databases. So we really care about customer and fraud. Back to IntelliJ. And in here, let me just open up the pom.xml and show you basically the configuration. So this is a multi-module project in here with some dependencies, but really what we are interested is, so have a look. So Spring Boot starter test, Open Feign, I'm going to show you this in a second. So this allows us to have a client so that we can communicate with our microservices. So one microservice can send a REST API call to another microservice. Then if I scroll down in here, Spring Cloud. So this is for distributed tracing, or actually Sleuth, and also Zipkin. So these two are for distributed tracing. And these right here, so this right here, so dependencies, this is basically all submodules will have all of these dependencies, right? So test and whatnot. So if I go to customer, for example, open up pom.xml, and in here, have a look. So this is where we now specify which dependencies that we want. So here I want to basically build a RESTful API using Spring Boot Starter Web. Also, I want to use Spring Data JPA in here. And I'm using also Postgres. And also in here, so this is me saying that this microservice will be a client when we connect to our Eureka server. And also we are basically saying that we want Zipkin and Sleuth. And I think maybe we don't have to include this because I already defined in the dependencies tab. So this is it. Then if I open up SRC and then resources, so this is how we basically connect to our database. So here we say data source. So Spring data source, the password is password. And then here Amigoscode, that's the username, and then the URL, localhost. So this is because we are running from IntelliJ and we're connecting to our Postgres container. And then the name of the database that we've just created, which was called customer. And then we have some other configurations. So here, how we connect to Eureka Server so that we really don't worry about ports, right? So I don't want to know about the ports when making one network call from one microservice to another. So that's resources. And then Java. So this is a typical application where we have our model, and this is using Spring Data JPA in here, where this entity will be mapped to our database. We are specifying the entity. This is the ID basically, and then we have first name, last name, and email. And we're also using Lombok so that we don't have to specify the getters and setters in here, nor the nor our constructors. And also we have a builder in here. Then we have the controller. So this is basically the endpoint. So API v1 customers, and from the request body we receive the request, which has only first name, last name, email, and this is a record. And then we have the request itself, which I've just showed you. And then we have the interface. So this allows us to basically start executing queries against our database for customer, so the customer entity. And then we have the customer service, and this is mainly for business logic in here, right? So we save and flush, then we make a network call to fraud, and if it's a fraudster, then we just throw an illegal state exception. Otherwise, there's a to do actually to send a notification. So you can see that there's not much going on apart from one microservice in here. Now let's basically get this microservice up and running, and for that I need to start Eureka Server. So here, because all the clients, so the microservices, will connect to Eureka Server, and then when they want to talk to each other, they actually ask the Eureka Server for the information where the other microservice lives. So here, if I open up SRC main Eureka Server, and it's very straightforward, you just basically need this annotation in here, and also Spring Boot application, and within the POM you basically need Spring Cloud Starter Netflix Eureka Server, whereas the microservices, they're using the client. So let's just start this. Oh, actually, I just pressed the wrong button. So here, run. There we go, up and running. And if I show you in here, so it says that, so there we go. So Tomcat started on port 8761. So let's just try and hit this endpoint. So let me open up my web browser, and then localhost column 8761. And there we go. So this is the server up and running. So Eureka Server. Now here, instances currently registered with the server. There's none, right? So let's run customer. So here, if I open up customer application again, so this is basically a simple main method, and this is how you run a Spring Boot application. So if I run this, there we go. And one thing that I want you to see in the logs is that if I scroll up, have a look, create table, customer, ID, email, first name, last name, and then setting the primary key. So this is basically JPA, which did all of this, actually Hibernate, which is running all of these commands. So now if I go back in here and reload to our Eureka Server, you can see that we have customer in here. So this now contains the information of how to reach customer. So if I spin up another microservice, I want to talk to customer, it only needs to know the application name, and then from the name, the server will actually resolve the IP address. So this is, again, the only reason why I'm using this is because it's easy to show you locally. But if you're using Kubernetes, there is no need for this. So now what I'm going to do is, so in here, I want to show you that the customer service in here. So in here, fraud check response, we have fraud client. And basically, this is a network call to fraud. So if I show you in here, so customer talks to fraud in here. So this is what this is doing. Now, this is using the fraud client, and fraud client is part of this package in here. And this is using Feign, or actually Open Feign. And this just makes it easy for you to basically build REST clients. And in here, I'm saying API v1 fraud check customer ID by passing the ID in here. And this right here is, so if I open up, so if I collapse customer and open up fraud, SRC, the layout is the exact same thing. We have a controller, and this is API v1 fraud check customer, and then some logic in here. So for now, all I'm just doing is I'm just saying it's fraudster false for now, right? This is just mimicking, and it's not doing real fraud checks. So the next thing is within the client, have a look, fraud. So here, I'm not saying localhost and then 8081, I think. So fraud is running on 8081. If I open up applications.yaml, 8081, so server.port. So I don't need to do none of this, right? I just said fraud because here is actually connecting to the Eureka server and finding where fraud lives. So this is the beauty of service discovery. So we don't worry about ports. So now let's actually open up the fraud application. Let's start. There we go. So this also creates the table for fraud. And now if I go back in here to my Eureka server and then reload, you can see that we have fraud and customer. Cool. So we are in a good place. Now, all we need to do is just send a request from, so in here, if I show you again, so from customer to fraud. So in here, I'm going to use a REST client within IntelliJ, so services, and I already have this file in here, and this basically allows me to send a post request to customer, and by sending this payload, so first name docker, last name con, email dockercon at docker.com, and if I send this request, you'll see that we have a 200 status code. So this is quite cool, which means that the request worked. Now to show you, if I open up PGAdmin in here, if I, for example, just open up fraud and then go to schemas, public, and then we have tables in here and fraud check history. If I basically just view data or rows, have a look. We have one row in here, and this was the check for dockercon. But if I show you customer also, so customer schemas and then tables, and then right click, view all rows, and you can see that we have dockercon in here. And both of these microservices were able to talk to each other via HTTP. And to be honest, this is it. Now, obviously, you know, I want to show you distributed tracing and whatnot, but this basically is the foundation that you need in order to get up and running with microservices. And to be honest, because we are using Spring Boot, things are super easy, and we just have to follow, you know, their specification and patterns on how to build microservices. And yeah, hopefully you can start building decoupled systems that each team can have full control and deploying these microservices. Now, obviously, what we need also is to containerize all of these. So you'd have a Docker file maybe for each microservice, which is not that difficult. And then you build an image, and then from that image, you can run containers, and you know where to go from there, right? So this is all for now, and I'll catch you on the next one. Assalamu alaikum.